Welcome, everyone. Thank you for joining us today. My name's Damian Curry. I'm the Community and Alliances Technical Director, and I'm joined today by Elijah. Yep.
Hi there, I'm Elijah Zupancic. I'm a solutions architect on the Communities and Alliances team.
Yeah, and today we're going to be talking about bringing an adaptive app to life with ecosystem partners. So, I think the thing we want to start with is, where did this all start? This all came out of an idea of, before we can start talking about adaptive applications, we have to start talking about modern applications. And this is something that was a big topic. And we were having lots of conversations around the company and with external people and going, what is a modern application? And this is what we were hearing, oh, well, it must be a microservice. It must be containerized. It must be cloud native. Well, it can't be a monolith, right? It can't be on bare metal. That's not modern. That's what we used to do. And the more we were talking about this, the more I was like, well, maybe it can kind of be all those things, right? It could be a microservice, but it doesn't have to be. And there are monoliths that are operated in a modern architectural way. So the more we were looking at this, we came out and there's, instead of being what it must be, we wanted to talk more about what it provides, because that's where the real power of the modern application architecture comes from. When we look at things like portability, the ability to run your infrastructure on any cloud, on-premise, multi-device, having that flexibility to move it where you need to. With that portability, it then adds in the scalability. When you can easily run it on multiple infrastructures, it allows you to easily scale globally to accommodate users and provide the best end user experience. With all of that too, it adds in resiliency. You have that failover. When you have that globally diverse application, you're not worried about a single site coming down and taking your entire user base offline. And then, of course, probably the most important part about the whole modern and adaptive app idea is agility. The ability to be able to quickly update your applications and your infrastructures via automated CI/CD pipelines. So that's all well and good to have these definitions and kind of being able to say, yeah, these are the reasons you want to build a modern application architecture. But the next thing came for, well, what does that actually look like? It's easy to say, oh, it's portable, it's resilient, it's agile, it's scalable. But what does that actually look like? So we ended up coming up with this diagram here to kind of explain everything that happens, and highlight those important parts about the modern application, and probably the most important part being everything being defined as code. So really you can kind of see, whether it's the DevOps team or the development team, everything rolls through a code repo, which feeds into a CI/CD pipeline, which feeds into the automation and orchestration platform. And then it goes out from there. And it allows you to stitch together all of these different tools in an automated manner to build these resilient, scalable infrastructures. And as part of this, there's a lot of partners that get involved there, whether it's the CI/CD pipeline, the automation and orchestration platforms, your external security and compliance components, key management, observability, and log management. All of these different pieces that are integral to having a modern application that then you can build into an adaptive application. So as we did more and more looking at this and we built this out, it became a really pretty diagram, but it's still just a concept. So what we really wanted to do was build a usable representation of this architecture. And this is where we came up with. So I'm going to go ahead and stop talking a little bit here, because Elijah's been driving most of the engineering effort on this front. So I want to let him dig in here and start giving everybody details on what we're working on.
So thanks for the introduction, Damian. With regards to reference architecture, what we wanted to do is we wanted to present a vision for how our products are intended to work with each other from the perspective of a Kubernetes cluster going out. And then we took this more broadly. How do our products work with the best-in-class tools and solutions, open source projects, in order to create a composable, reliable, debuggable, scalable, and repeatable Kubernetes environment. With all that in mind, we found that by assembling the reference architecture, we were able to naturally start to illustrate modern application design principles. And we were able to do it in such a way that it doesn't come across as a unrealistic toy architecture. For me, this was like a really important thing. This has to be illustrating production principles in the architecture. I see so many demos and code examples that just will not work in a production environment. So this is really one of our key tenets in building this.
That and also being able to be deployed by anyone, right? How many demos do you see that take, tons of hand holding and customization? So you can't really play with it yourself. So we really wanted this to be, anybody can grab it and use it.
Exactly. And the other principle is that it should be stealable. Is we want somebody to be able to go take components of this and be like, hey, here's this component. I don't need the whole thing, but I need to see how to really use this in Kubernetes with my application. Okay, I see working code. Code is currency. I mean, I don't want to go fiddle around in 80 pages of documentation. I want to see how this actually logically all lines up and works. So we've composed all these components in such a way that they can be taken in isolation and adopted in your architecture without having to bring over necessarily everything else. And really, our expectation is that everyone can go fork it, modify it, and change it to something that works for them. And we're building this out in the open. It's 100% open source. Our project management, roadmap, bug reporting is all there out on GitHub, and pull requests are welcome.
So yeah, I mean, on top of just not just welcome, we're highly encouraged. We would love anything. So we're trying to build this as modular and pluggable as we can, so that different tools can be brought in. At this time, we're kind of at kind of the V1 early release, and so we kind of have it broken down into a few main things. We're leveraging Pulumi with Python for all of the infrastructure as code and automation piece of it. We're then using NGINX Plus for being pulled from Docker Hub. You can using AWS EKS, got log management in there and some cert manager, and then we got a demo app. So so I guess let's start digging in and see exactly what we're doing here.
Okay, well now let's talk about what it is. Although I say reference architecture in the singular, it's really a plural. Right now we've currently built is built in Pulumi, but in the future we could be doing parallel versions in, say, Terraform CDK, or just straight up bash scripts in YAML. And our current example or reference architecture is deploying on AWS and standing up all the Kubernetes infrastructure on AWS. However, in the future, we could be using other clouds or even vSphere. Once Kubernetes is stood up, the reference architecture builds an image of NGINX Kubernetes ingress controller, pushes it to a repo, and installs the ingress controller using that newly built image and deploys an application. This piece that is happening all in Kubernetes, is totally portable, and it isn't tied to the underlying cloud. So that's really everything here under ECR down, this little blue kick image build down, that piece you could take and apply to other Kubernetes deployments. Additionally, you probably noticed here is that we also in this architecture install log and cert management components as well.
Yeah, definitely. And like we said, this is kind of our first release here, and for our final V1, as we're calling it, we're going to add in a few other pieces here that will kind of bring us into the fully adaptive apps space. First and foremost, getting the observability turned on there with Prometheus and Grafana. We're looking at building a full CI/CD pipeline for the application and all of the infrastructures by leveraging the JFlog platform and their different tools that they've run in there, um, as well as building in a performance testing framework as part of this, which personally is one of the things that I'm more excited about, because not only are you able to stand it up and, do testing against it and make changes, but you can have a repeatable testing framework so that when you do make those changes, you can tell, well, did this hurt my performance? Did this help my performance? And just being able to baseline it and just being able to have actual numbers to associate with that information. We're also looking at, building in support for Rancher. They have some really interesting management systems for Kubernetes, as well as their own Kubernetes distribution. We're currently using the Bank of Anthos application that is obviously built by Google, and we're looking at forking that repo and kind of taking out some of the logic, leveraging a lot more of the functionality that's in our ingress controller that can take some of that logic out of their front end Python app and just offload it there, so you can get a better real world example of, what can you do with the ingress controller? How can you offload some of that application level logic so you don't have to worry about it in your app, and you can just let the ingress controller manage it. And one of the other things is we're looking to leverage some of the new stuff that Docker's coming out with in order to have a containerized deployment system, so that you don't have to jump through all the hoops of making sure you have the right prereqs and all of that on your local machine to deploy this. Instead, you can just, pull down a container, have it all pre-configured and ready to go, and just really get up and running as quickly as possible. So I guess now let's jump into it, and let's go start digging through the code, and let's give everyone a walkthrough through, how we're doing this, what the deployment looks like, and take it from there.
Okay, let's take a look at what the reference architecture's code base looks like. Please take a note that this is within the NGINX Inc. GitHub organization, and the name of the project is Kick Reference Architectures. And we're within a subdirectory here, Pulumi AWS, because we're dealing with a reference architecture that provisions on AWS using Pulumi. So let's take a look at what we have here. We have some getting started documentation here, and it basically, gives you the rundown on what you need to get up and running. What is probably the biggest points that you should know is you'll need Git, you'll need Python, you'll need Make, and you'll need Docker. And refer to the docs for help. Or just reach out to us if you get stuck. But what I really want to show off is how Pulumi allows you to define your infrastructure in code. So what we're looking at here in this file is a VPC that's going to be used by EKS that is defined entirely in Python code. And one of the key principles here that's interesting is that Pulumi works by you defining what you intend for the infrastructure to be. And if it fails, that infrastructure is either not created, or it's created in a half state that you can then rerun Pulumi until you get to the end intended state. So this is a bit different than the other infrastructure SDKs out there that just don't work by this kind of intention-driven workflow. So kind of going through this code, we'll see that we've defined parameters of a VPC, our gateway, our route table, but also this is down here is where it gets particularly interesting, is beyond just using Python like a fancy configuration language, we can actually start to use programming constructs. So for example, we can go look up the names of all of the availability zones within a region, and then we can dynamically create a subnet per availability zone, all in a loop, right? just the way it should be. Backing out, we can take a look at, for example, our demo application, Anthos, or the Bank of Anthos. And we can see that we were actually able to bring references from other projects defined in Pulumi that already completed. We could pull in variables from them and use them in this project definition. Moreover, we could modify YAML soup that was brought in from this application's migration. It originally came with a ton of YAML files that defined how it works in Kubernetes. And we can actually ingest those YAML files and programmatically modify them. So you'll see that in some of the config map pieces here in this file. You can see that we can define our authentication parameters, or I should say secrets. These can be linked into Pulumi's own secrets handling logic. I encourage you to go poke around and explore this on your own. Other interesting areas are things like Kick Image Build. This is the Pulumi project where we define and build NGINX Kubernetes ingress controller from source. It's done by invoking an external process that runs make, which make in turn runs a Docker build. This whole process is automated, from checking out the project from GitHub with the latest source code, to invoking make, to recording the output of the Docker build process. All of that is automated and incorporated into this Pulumi workflow. When that piece is finished, we then push it out to ECR that is defined here. Really, this is totally a kind of a flexible approach to defining infrastructure. And kind of what ties in all of these projects together is this bash script right here, start all. If you scroll to the bottom, you can see that we just quite simply go through each one of these directories that is a Pulumi project, and we run Pulumi up in each one of those directories, and sequentially start to stand up our infrastructure. If any one of these steps fail, the script stops there. You can go into the directory and you can manually inspect why it failed. Perhaps Amazon's having a bad day, and you can just go and rerun start all again and see the infrastructure come up. So with that said, let's go take a look at the command line and look at what this looks like when you actually are running it. So here's a project that we were just exploring on GitHub. When we do our initial run, we want to run a setup VM. That will set up all the Python, download the Python, Node, and other dependencies, and install them in the VM directory. When we're ready to go run the project, we can just go source, VM, bin, activate, just like we do for most Python projects that are using virtual environment. And then let's go start this. What is it going to look like to deploy all this infrastructure that we defined in Python out to AWS? And here's a taste of it. We see that first we're standing up our VPC, and then after VPC, it goes and stands up EKS. As I mentioned before, these are separately defined Pulumi projects. So each one of these rainbow banners you're seeing is a separate directory within the reference architecture that is a separate Pulumi project. And they are chained together and they have a sequential execution. And there are dependencies where they depend on values from another project. Now we've moved along to ECR, Elastic Container Registry. That's being stood up. And now we are building the ingress controller from source. Um, so this is downloading the GitHub, the code from GitHub, running make, and then Docker build. Now that that's built, we are pushing that image out to that ECR instance we provisioned on AWS. And now we're deploying the NGINX Kubernetes ingress controller using Helm to that EKS cluster we stood up. And this is using that custom built ingress controller that we had just made. Now, Logstore is being configured and deployed to our Kubernetes cluster. And right on the heels of this one, I believe it's FileBeat that is going to be deployed as well. Okay, with this completing here soon, now we have Cert Manager, and this is giving us our TLS certificates for integrated within Ingress Controller, so that we're not just serving insecure traffic on our demo application. Okay, that's completing. And if we get to the next step here, yeah, so this whole process does take a while to run. You'll find that depending on the weather today at AWS, the total time to completion may differ significantly. It also may differ based on the region you're in. Okay, now we're deploying the Bank of Anthos. That's our demo application. This is exciting. Really, we're looking at a one-click deployment of an entire Kubernetes cluster and application. So let's go take a look at this demo application out on the web. So we'll go take a look at the Pulumi project that deployed Ingress Controller. We'll do Pulumi stack output, and this will show the variables output from Pulumi when it ran. Here we've got the address for the front-end load balancer for Kubernetes Ingress Controller. And then we're going to go to that address, and we're going to go look at our demo application. Yay, our application is up and running. So as you can see, this is the test application that's running on our newly stood up Kubernetes deployment, running NGINX Ingress Controller. I think we can even go and take a look at the network here and inspect some requests, and you should be able to see that this is all being served via NGINX. Well, thank you for taking the time to see this demo in action.
All right. Well, thank you very much, Elijah, for taking us through all of that. And thanks everyone for joining us. We hope this was an interesting thing, and we look forward to having some pull requests and some engagement from the community.
Thank you all. I look forward to hearing from you.
Thanks, everyone.